October 1942, Wright Field, Ohio. Test pilot Bob Chilton climbed into the cockpit of a P-51 Mustang that looked identical to every other Mustang he'd flown. Sleek, elegant, its lines so clean they seemed to slice through the air, even while still on the runway. But beneath the cowling sat something entirely new, something the British claimed would change everything. A Rolls-Royce Merlin engine. Chilton had flown the standard P-51 dozens of times with its American Allison engine. At low altitude it was superb, fast, agile, and a delight to handle. But above 15,000 feet it faltered. The Allison's single-stage supercharger couldn't breathe in the thin air. And at the altitudes where B-17 bombers battled their way toward Germany, 25,000 to 30,000 feet, the P-51 became almost useless. That failure meant American bomber crews were dying, sometimes losing 25% of their men on a single mission. Young airmen burned alive over Germany because their escorts couldn't reach them or stay with them to the target and back. The Army Air Forces needed a long-range, high-altitude escort fighter desperately, and they needed it yesterday. Chilton eased the throttle forward. The Merlin came alive, not with the sharp whine of the Allison, but with a deep, thunderous growl that shook the ground. Like a locomotive gathering steam, the Mustang roared down the runway and clawed into the sky. At 10,000 feet, Chilton leveled off, everything perfect. At 15,000 feet, where the Allison would gasp for air, the Merlin kept pulling strong. At 20,000 feet, its two-stage supercharger kicked in, slamming Chilton back into his seat. At 25,000 feet, he shoved the throttle to the firewall. The Mustang exploded forward, 400 MXHP, 410, 420. "Right field, this is Chilton," he radioed, his voice tight with excitement. "What's your status, Bob?" Came the reply. Chilton glanced at his gauges. Altimeter, 28,000 feet. Airspeed 432 mph. Fuel tank still half full. "This isn't the same airplane," he whispered. "This is something else entirely. Before we reveal how this transformation happened and how it changed the course of the war, tell us where you're watching from. Whether you're in Detroit or Delhi, London or Los Angeles, we'd love to know where our aviation history community is tuning in from today. Drop your location in the comments below." Back on the ground, Chilton climbed out of the cockpit and strode straight to the engineers. "How soon can we get these into production?" The lead engineer shook his head. "That's the problem. We can't." "What do you mean we can't? You saw what it did up there." "The Merlin's a British engine. Rolls-Royce builds them in England. They're already running at full capacity, making engines for Spitfires, Hurricanes, and Lancasters. They can't spare any for us." Chilton stared at him. "So we've found the fighter that can win the war, and we can't build it." "Not unless we find another way to make Merlins," the engineer replied, pulling out a telegram. "There might be one option. Packard Motor Company in Detroit. They've been building Merlins under license for the British. If we can convince them to scale up production for American fighters, then do it," Chilton cut in. "Because I just flew the future up there, and every day we delay, more bomber crews die." The engineer nodded. "I'll make the call." What neither of them realized was that the simple idea of producing more Merlins would trigger one of the most complex engineering challenges of the entire war eventually, creating what pilots would call the locomotive of the skies. The Merlin engine hadn't started as a weapon of war. It began as a pursuit of speed. In 1933, Rolls-Royce, the famed British luxury car maker, began developing a new aircraft engine for the Royal Air Force. The mission was clear: more power, more reliability, and better high-altitude performance than anything that existed. Chief Engineer Ernest Hives assembled the brightest minds in British aviation. Working in secrecy, they tested, refined, and reimagined the limits of engine design. The result was the Rolls-Royce Merlin, a liquid-cooled V12 producing 1,030 horsepower in its first version. But the true breakthrough wasn't the raw power. It was the supercharger. Most engines of the era used single-stage superchargers to force more air into the cylinders at altitude. But beyond 15,000 feet, they simply couldn't keep up. The Merlin introduced a two-stage, two-speed supercharger. The first stage compressed the air once, the second compressed it again, and a sophisticated control system shifted gears automatically with altitude. The outcome, full power all the way to 40,000 feet. It's not just an engine, Hives told his team. It's a revolution. The Merlin first entered combat in 1937, powering the Hawker Hurricane, then the Spitfire in 1938. When war broke out in 1939, these Merlin-powered fighters became Britain's shield, and during the Battle of Britain in 1940, the deep, thunderous roar of Merlin engines filled the skies, so unlike the shrill whine of German planes. That sound meant the RAF was in the air, fighting back, refusing to surrender. It was the sound of defiance, the sound of survival. British civilians learned to recognize it instantly. When they heard that sound, they looked up and cheered. German pilots learned to recognize it too, and they learned to fear it. But by 1941, Britain faced a crisis. Rolls-Royce was producing Merlin engines as fast as humanly possible, but it still wasn't enough. The RAF needed power plants for Spitfires, Hurricanes, Mosquitoes, and Lancaster bombers. Production was maxed out. There was no spare capacity. And across the Atlantic, the Americans were beginning to realize they needed the Merlin too. "We have a problem," Air Marshal Charles Portal told a gathering of British and American military leaders in early 1941. "The Merlin is the best aircraft engine in the world, but we can't build enough of them." An American general leaned forward. "What if we made them for you?" Portal raised an eyebrow. "In America, we have the factories, the workers, the capacity. If you share the blueprints and grant a license, we can produce Merlins by the thousands." Portal hesitated. Sharing Britain's most advanced military technology with another nation, even an ally, was a serious risk. But the alternative was far worse. "There's one company that might manage it," he said finally. "Packard Motor Company. They've already been building a small number of Merlins for us under license. If anyone can scale up production, it's them." "Then let's talk to Packard," the American general replied. What nobody mentioned in that room was the monumental technical challenge that lay ahead. The Rolls-Royce Merlin wasn't just complex, it was British. Designed with British measurements, British materials, and British manufacturing techniques. America would have to rebuild it from the ground up. Colonel Jesse Vincent walked into the Packard Motor Company headquarters in Detroit, carrying a briefcase filled with blueprints, and a problem that seemed impossible. "Gentlemen," he said to the gathered Packard engineers, "the United States Army Air Forces needs you to build the most advanced aircraft engine in the world, in huge numbers, starting immediately." He opened the case and spread the Rolls-Royce Merlin drawings across the conference table. Chief Engineer George Christopher picked up one of the sheets, studied it, and frowned. "Colonel, these are all in metric." "I'm aware," Vincent replied. "We don't work in metric," Christopher said. "Every tool and machine in this factory is calibrated in inches and feet. Pounds, not kilograms. We'd have to convert everything. There are over 6,000 individual drawings," he added after a pause. "Thousands of parts. Tens of thousands of dimensions. Every single one must be converted from metric to imperial, verified and retooled." "How long?" Vincent asked. "Months. Maybe a year." Vincent's jaw tightened. "We don't have a year. Bomber crews are dying over Germany right now because they don't have fighter escort. We need these engines in 6 months. Christopher stared at him like he'd just asked for a trip to the moon. "Colonel, that's impossible." "I know," Vincent said quietly. "Do it anyway." Christopher looked around the table. His engineers stared back, half determined, half terrified. Finally, he nodded. "All right. But we'll need help. Direct contact with Rolls-Royce, samples of every part, and full authority to modify anything that doesn't fit American production." "You'll have it," Vincent promised. What followed became one of the most intense engineering races of the entire war. Packard engineers worked day and night, translating, redesigning, and inventing entirely new manufacturing methods. The challenges seemed endless. British bolts didn't match American threads. British steel alloys behaved differently from American metals. British tolerances were measured to the thousandth of an inch, and one error could cause an engine to explode at 25,000 feet with a pilot inside. This bolt, one engineer said, holding up a tiny piece of metal, is specified at 8.5 millimeters. That's 0.3346 inches. But we don't make that size. The closest we have is 1132, or 0.3438 inches, a difference of 0.092. So use the 1132, another suggested. Can't, the first replied. That 0.0092 difference means the bolt won't seat right. Under stress, it could shear off. Engine failure. Dead pilot. So what do? We make new bolts, custom ones. Exactly 0.3346 inches. And new dies to cut them. And new quality checks to test them. Multiply that problem by 10,000 parts, and you begin to understand the scale of Packard's challenge. But they didn't give up. Rolls-Royce engineers were flown over to consult. Prototype engines were built and pushed to destruction. Every failure taught them something. Entirely new assembly lines were designed, dedicated solely to Merlin production. Slowly, painfully, impossibly, it began to work. In August 1941, just 6 months after Vincent's impossible order, the first American-built Packard Merlin engine rolled off the Detroit production line. It was designated the Packard V1650. Engineers held their breath as they mounted it on a test stand, connected the fuel lines, and hit the starter. The engine coughed once, twice, then came alive with that unmistakable, deep, thunderous roar. The locomotive of the skies had arrived in America. By early 1943, Packard's Detroit plant was producing Merlin engines at a rate Rolls-Royce had once thought impossible, never dreamed possible. 400 engines per month, then 600, then 800. The factory ran 24 hours a day, 7 days a week, 3 shifts of workers, many of them women as men went off to war, assembled the intricate engines with a precision that would have impressed a Swiss watchmaker. Rosie the Riveter wasn't just a poster. She was real, and she was building the engines that would win the war. Each Merlin contained roughly 10,000 individual parts. Everyone had to be machined to tolerances measured in thousandths of an inch. Every engine had to be assembled, tested, disassembled, inspected, reassembled, and tested again before approval for flight. Quality control bordered on obsession. Inspectors checked components multiple times. Test runs lasted hours, pushing engines to their limits to expose any weakness before combat. A bad engine doesn't just fail, the quality supervisor told his team. It fails at 30,000 feet over Germany with a 20-year-old kid inside who's counting on us to bring him home. We don't ship anything that isn't perfect. The workers took that to heart. Stories spread of inspectors rejecting entire batches of parts for microscopic flaws invisible to the naked eye, and of assemblers staying late, unpaid, to double-check their work. They knew what was at stake. Meanwhile, at North American Aviation in California, engineers were preparing to install the Packard-built Merlin into P-51 Mustangs. The conversion required major modifications, new engine mounts, cooling systems, and propeller assemblies. But when the first production P-51B rolled out with its Packard Merlin in late 1943, test pilots confirmed what Bob Chilton had discovered a year earlier. This was a different airplane altogether. Maximum speed, 437 mph at 25,000 feet. Service ceiling, 41,900 feet. Range with external tanks, 1,750 miles. For the first time in the war, the Allies had a fighter that could escort bombers all the way to Berlin and back. This changes everything, General Jimmy Doolittle said after his first flight in the Merlin-powered Mustang. The Germans won't know what hit them. He was right. In December 1943, the first P-51B Mustangs reached England and were assigned to the 354th Fighter Group, the Pioneer Mustangs. Their mission, escort B-17 and B-24 bombers deep into Germany. On December 13th, the Mustangs flew their first long-range mission to Kiel, Germany. The Luftwaffe rose to intercept, expecting the American fighters to turn back as always when fuel ran low. But the Mustangs didn't turn. They stayed with the bombers all the way to the target, and when the German fighters struck, the P-51s ripped into them with a fury the Luftwaffe had never seen. The Mustangs were faster than the Bf-109s, more agile than the Fu-190s, and they had the range to chase their opponents all the way back to their own airfields. "It's not fair," one captured German pilot complained. "You have fighters that can go anywhere, do anything. How are we supposed to fight that?" The answer was they couldn't. By early 1944, P-51 Mustangs were arriving in England by the hundreds. Packard was building Merlin engines faster than North American could produce airframes to house them. The Detroit plant had become the beating heart of American air power. Workers called the Merlin the locomotive of the skies, not just for its deep, powerful roar, but because it pulled the entire Allied air campaign forward like a locomotive pulling a train. And over Germany, Luftwaffe pilots learned to dread that sound. The deep thunder of Merlin engines meant the Mustangs were coming, and when the Mustangs came, German pilots died. The transformation was complete. The P-51 Mustang, once a promising but limited fighter, had become the most lethal air superiority weapon of the war. And it was all because of an engine built in Detroit by workers who knew that every bolt they tightened, every part they fitted, every engine they tested, was bringing American boys home alive. March 6, 1944, Berlin, Germany. Captain Don Gentile of the 336th Fighter Squadron shoved his P-51 Mustang into a steep dive, the Packard Merlin screaming as he closed in on a German Bf-109. This was the first American escort mission all the way to Berlin, the heart of Nazi Germany, 600 miles from England, a distance unimaginable just 6 months earlier. But with the Merlin engine and drop tanks, the Mustangs had made it. And now they were hunting. Gentile's gun sight locked on the 109. He squeezed the trigger. 650 caliber Brownings roared. The German fighter exploded in a burst of debris. "Splash one," Gentile said calmly. Around him, the sky was alive with contrails and tracers as Mustangs tangled with German fighters in massive dogfights. But the outcome was never in doubt. The P-51s were faster, deadlier, and flown by pilots who had been training for this moment for months. By the time the bombers turned for home, the 336th had destroyed 11 German aircraft without losing a single Mustang. "How's your fuel, Gentile?" His flight leader called. Gentile checked his gauge. "Enough to get home, with some to spare." "Then let's go hunting on the way back." They did, and they found more German fighters trying to regroup. By the time the Mustangs crossed back into friendly skies, Gentile had 4 confirmed kills to his name. Kills for the day, 17. The mission marked a turning point. For the first time, American bombers had struck Berlin with full fighter escort from takeoff to landing. The Luftwaffe had thrown everything it had at the raid and been shattered. "The Jerrys are scared," one bomber pilot said after landing. "You could see it. When they heard those Merlins coming, they scattered. They know they can't win anymore." He was right. The strategic balance had shifted. Before the P-51, German fighters could attack American bombers with near impunity, knowing the escorts would have to turn back. Now the escorts could stay all day, and the Luftwaffe was bleeding to death. German fighter losses soared. During Big Week, a series of massive raids in February 1944, the Luftwaffe lost over 500 fighters, and more critically, many of its best pilots. Pilots who could not be replaced. "We're not just shooting down their planes," General Doolittle told his staff. "We're destroying their ability to train new pilots. Every ace we kill is 100 rookies who'll never learn how to fight. We're breaking them." And the Mustang was the weapon doing the breaking. By D-Day, June 6, 1944, the Allies had achieved total air superiority over Europe. German fighters barely appeared above the Normandy beaches. The Luftwaffe had been mauled so badly in the preceding months that it couldn't mount any real defense. "Where is the Luftwaffe?" German soldiers on the ground asked bitterly as Allied planes strafed them unopposed. The answer: shot down by Mustangs, destroyed on the ground by Mustangs, hiding in fear of Mustangs. The P-51 Mustang would ultimately be credited with destroying 4,150 enemy aircraft in the air, more than any other Allied fighter, and another 4,131 on the ground. The kill ratio was staggering. 19 German aircraft destroyed for every Mustang lost in combat. And at the heart of every one of those Mustangs was a Packard-built Merlin engine, the locomotive of the skies, crafted by American workers in Detroit and shipped across the Atlantic to help win the war. Captain Chuck Yeager, who would later become the first man to break the sound barrier, flew P-51 Mustangs in combat over Europe. Years later, he described what it was like to fly a Merlin-powered Mustang in battle. "You'd be at 30,000 feet and you'd see German fighters below you," Yeager recalled. "You'd roll over, push the throttle forward, and that Merlin would just sing, that deep, powerful sound that told you had all the power in the world. You'd dive at 500 miles an hour, and the Mustang was rock-solid, stable, responsive. You'd get on a German's tail, and he couldn't shake you, couldn't outrun you, couldn't outturn you. He was dead, and he knew it. And when you pulled the trigger, saw your tracers hit, saw him smoking and going down, you didn't feel happy exactly, but satisfied, like you'd done your job, like you'd protected the bombers, like you'd brought your guys home." Yeager paused, remembering. "The Mustang wasn't just a fighter plane," he said. "It was a weapon system. The airframe, the guns, the pilot, all good. But the heart of it, the thing that made it all work, was that Merlin engine. Without the Merlin, the Mustang was just another fighter, good but not great. With the Merlin, it was the best in the world. And that made all the difference. The numbers prove Yeager right. Of the top American fighter aces in Europe, most flew P-51 Mustangs. The top ace, Major George Preddy, scored 26 of 83 victories in a Mustang before being killed by friendly fire in December 1944. But the Mustang's impact went far. Beyond individual kills, it fundamentally altered the strategic balance of the air war. Before the P-51, the Allied bombing campaign was faltering. Losses were unsustainable, targets survived, and the Luftwaffe held the advantage. After the P-51 arrived, the bombing offensive became unstoppable. German industry was systematically reduced to rubble. Oil refineries, ball-bearing plants, aircraft factories, all destroyed. And the Luftwaffe could no longer stop it. It was too busy fighting and dying against the Mustangs. The P-51 Mustang was the most important aircraft of World War II, historian Stephen Ambrose wrote. Not because it was the best fighter, though it was, but because it made strategic bombing possible. And strategic bombing broke Germany's ability to wage war. At the center of that achievement was an engine designed by British engineers, built by American hands, and fitted to an American airframe that became a legend. The locomotive of the skies had pulled the Allies to victory. By war's end in 1945, Packard had produced 55 523 Merlin engines, each a masterpiece of precision engineering. Built to tolerances once thought impossible, the workers who made them, many of whom had never set foot in a factory before the war, had become some of the most skilled manufacturing technicians in the world. They took British blueprints written in foreign measurements and turned them into an American industrial triumph. "We didn't just build engines," one Packard worker recalled years later. "We built hope. Every engine that left our factory meant another pilot had a chance to come home. Another bomber crew had protection. Another mission could be flown. We worked 12-hour shifts, 6 days a week. Our hands were always dirty, our backs always hurt, but we never complained because we knew what we were building mattered." The impact of their work still echoes through history. Work was measurable. In 1943, before the P-51 Mustang became widespread, the 8th Air Force was losing an average of 176 bombers each month. By late 1944, with Mustangs providing full escort, That number had fallen to just 40, a 77% reduction. Each bomber carried a crew of 10 men. That meant the Mustang and the Merlin engine that powered it was saving roughly 1,600 American lives every month throughout the war. That added up to tens of thousands of men who came home because a Packard worker in Detroit had tightened a bolt just right, or an inspector had caught a flaw, or an engineer had solved an impossible problem. The Merlin engine also powered other legendary aircraft, the British Spitfire, which saved Britain in the Battle of Britain, the de Havilland Mosquito, the fastest bomber of the war, and the Avro Lancaster, which carried destruction deep into Germany's cities. But it was in the P-51 Mustang that the Merlin achieved its greatest fame. The combination of North American aviation's brilliant airframe design and Rolls-Royce's revolutionary engine, built in vast numbers by Packard, created something greater than the sum of its parts. It created a weapon that changed history. After the war, many P-51 Mustangs were sold as surplus. Some went to foreign air forces. Others were bought by civilians and converted into racing planes. A few were lovingly preserved in museums. And at air shows across America, when a restored P-51 Mustang fires up its Packard-built Merlin, crowds still gather to hear that sound, that deep, thunderous roar. The sound that once meant salvation to bomber crews over Germany. The sound that once meant death to Luftwaffe pilots. The unmistakable sound of the locomotive of the skies. In 2024, fewer than 200 P-51 Mustangs remain airworthy worldwide. Each one is a priceless artifact, maintained by dedicated volunteers and aviation enthusiasts who understand the immense historical significance of these machines. At the National Museum of the United States Air Force in Dayton, Ohio, a P-51D Mustang sits in a place of honor. The placard beside it tells the story of its combat record: 47 missions, 3 aerial victories, 0 losses. But next to it, another placard tells a different story: the story of the Packard Merlin engine. This engine, the placard reads, represents one of the greatest industrial achievements of World War II. It combined British engineering, genius, with American manufacturing power to create the engine that gave the Allies air superiority and helped win the war. Visitors stop to read the words. Some take photos. A few, usually older men, veterans themselves, stand silently for a moment, remembering. One elderly man, a former B-17 pilot, gently touches the Mustang's propeller. "This airplane saved my life," he says quietly to his grandson. "I flew missions over Germany in 1944. We'd lost so many planes, so many friends. Every mission felt like a death sentence. Then the Mustangs showed up, and suddenly we had a chance. When you heard that sound, that deep roar of the Merlins, you knew you were going to be okay. The Mustangs were there. They'd protect you." His grandson stares at the sleek fighter plane. "It's beautiful," he says. "It's more than beautiful," the old pilot replies. "It's the reason I'm standing here today. The reason I got to come home, get married, have your father, and meet you. All because of this airplane and the engine that powered it." He pauses, his hand still resting on the propeller. "People talk about the greatest generation, about the sacrifices we made. But I think about the people who built this engine, the workers in Detroit who never fired a shot, never flew a mission, never saw combat. But they won the war just as surely as any pilot or soldier. Every bolt they tightened, every part they assembled, every engine they tested, they were saving lives, my life. And they did it with a precision and dedication that still amazes me." His grandson nods slowly, beginning to understand. "The locomotive of the skies," the old pilot says, reading the placard. "That's what they called it. And it pulled us all the way to victory. The story of the Packard Merlin engine is more than a story of technology. It's a story about what happens when brilliant engineering meets relentless industrial determination. The Rolls-Royce Merlin was a masterpiece of British design, a revolutionary engine that pushed the limits of what was mechanically possible. But Britain alone couldn't produce enough Merlins to meet the demands of a global war. Packard Motor Company took that British masterpiece and did something equally extraordinary. They figured out how to mass-produce it. They converted 6,000 metric blueprints to imperial measurements. They invented entirely new manufacturing techniques. They trained workers who had never built an aircraft engine to work to tolerances measured in thousandths of an inch. And they did it all in just 6 months, a timeline that should have been impossible. The result, 55 523 engines that powered the aircraft that won the air war over Europe. Engines so reliable, so perfectly built, that many are still running today, 80 years later. The Merlin engine represents the very best of both British and American engineering. Aviation historian Barrett Tillman wrote, "British innovation and American production, British precision and American scale. Together, they created something neither nation could have achieved alone." The P-51 Mustang, powered by the Packard Merlin, became the symbol of Allied air supremacy. It was faster than German fighters. It could fly farther. It was more reliable, and there were thousands of them, an endless stream of silver fighters that filled the skies over Europe. And ground the Luftwaffe into dust. German pilots called them the plague, and they learned to fear both the sight of Mustangs and the sound of their Merlin engines. That deep, powerful roar that meant death was coming. But to Allied pilots and bomber crews, that sound meant something entirely different. It meant protection. It meant hope. It meant they had a chance to finish their mission and come home alive. When you heard the Merlin, one B-17 pilot wrote in his diary, you knew you were going to make it. The Mustangs were there, and nothing could touch you. The locomotive of the skies had earned its name. Just as steam locomotives had revolutionized transportation in the 19th century, the Merlin engine revolutionized air warfare in the 20th. It was powerful, reliable, and built in numbers that overwhelmed the enemy, and it changed the course of history. Today, when a restored P-51 Mustang takes to the skies at an air show, something almost magical happens. The crowd falls silent as the pilot begins the startup sequence. The Merlin coughs once, twice, and then roars to life with that unmistakable growl. Children point in awe. Adults raise their phones to record. Veterans stand straighter, some with tears in their eyes. And for a moment, history itself seems to breathe again. The Mustang taxis to the runway, its exhaust stacks glowing a faint cherry red. The pilot eases the throttle forward, and the fighter surges ahead with a thunder that shakes the ground. Rotation, liftoff. The Mustang climbs steeply, the Merlin pulling it skyward with effortless strength. Then with a flick of the wrist, the pilot rolls inverted and pulls through. The Mustang's wings catch the sunlight as it screams past the crowd at over 400 miles per hour. The sound is overwhelming, not the piercing shriek of a jet, but a deep, visceral roar that you feel in your chest. The sound of 12 cylinders firing in perfect rhythm. The sound of 490 horsepower unleashed. The sound of the locomotive of the skies. That sound, an elderly man murmurs to his wife, is the sound of freedom. That's what saved us. That's what won the war. He's right. The Packard Merlin engine, built by American workers in Detroit, designed by British engineers in Derby, installed in American fighters in California, was one of the decisive weapons of World War II. It gave the Allies air superiority. It protected bomber crews. It broke the Luftwaffe. And it helped bring the war to its end. But more than that, it represents something deeper, something essential to the Allied victory, the power of cooperation, industrial ingenuity, and the determination of ordinary people to accomplish extraordinary things. The men and women who built those Merlin engines in Detroit weren't soldiers.